everyone. So today our group would like to present about our project, which is a piano keypad kit, and this is our overview in this presentation. So including introduction, circuit diagram, code explanation that will be make you guys much more understand about our projects and experiment. So let's get started with the introduction. What is piano keypad kit? So piano keypad kit is a piano that made by using a microcontroller components such as Arduino board, bezel, and keypad, so on. So each number of keypad will be made different sound of piano note key sound. So the reason why we choose this type of project, which is piano keypad kit, is because first we want to apply the knowledge that we gain from the course, which is a microcontroller and application, to implement the stuff that user can use it in the real life, and also it can be reduce the cost in terms of user want to use or to play the piano, but you know that piano has the expensive cost. So this can be the faster piano that user can be used for learn about the music. And this is the main component that we use in this project. So first is Arduino board. So Arduino board is the small microcontroller based circuit board that act as the brain of the Arduino project. So it allows user to read the input. Yeah. And second is keypad. So keypad is the one-off component in this project that we use as the input. So when user press the button, so the keypad will be loud. So the sound will be loud. And the third is bezel. Bezel works as the speaker, which is the sound that produce or the sound that is come from the keypad will be out of this component. So next, my friend will be explain about the circuit diagram.
This is diagram that show our project connection, which is Arduino piano. For my project, I use Arduino breadboard, keypad, LED segment, and buzzer. I use buzzer to make the different frequency that make the sound do re mi fa sol la ti do, and keypad to input the sound. LED 7 segment to show the note of each key. The breadboard, I want the upper is the voltage and the lower is the ground. The keypad connected to pin number 2 to 9. And the buzzer connected to pin number 10 and connected to the voltage and ground. And the 7 segment connected to pin number 11 to 13. And A0 to A3. But I'm not connected the dot. The dot is empty. And we use the resistor 330 ohms before connected to the 7 segment. This is overview of our diagram.
So the next I will be explain about the code that what is the code that we use in our project. So in this code I will be explain in the section. Okay, so first section will be about the keypad. So as we know that we use the keypad as the input, so we set over here the keypad. Yeah, over here. So this is a 1, 2, 3, A, 4, 5, 6, B, and so on, which is the value on the keypad, right? Okay, then this is we use to map the keypad, to make the keypad. Yeah, and this section is for the keypad. Yeah, and the next section is to be like we set the constraint, or we set the constraint with the value. So this is a pin of the bezel. Okay, and this is tone stars. Tone star, that means that the like a start of the tone, which is start of the tone of the sound. Yeah, and over here is playing. So is playing is the boolean that if is playing is true, so the piano keypad kit will be playing or the sound will be loud. Okay. And over here is keynote. So the keynote that we use in this project, which is the 1 to 8. So actually in this keypad we can press only 1 to 8 because we set the note key only 1 to 8. Yeah, depend on, not depend on, so recording to the note of the piano. And this is the frequency. So number one will be equal to frequency 262. That means the frequency over here will be equal to the sound of the piano, do, re, mi, fa, sol. So this is a do, this is a re, this is a mi, fa, sol, la, ti, and do. Okay, and this is note label. So note label is the label of the note. So do will be equal to the C, re, di, mi, e, and so on. Okay. And in this project also we use the 7 segment to display the letter of the note. So for the example, when I press bottom one, the 7 segment will display the C because the one will be set as a do and C is the letter of the do key. Over here we set the pin of the 7 segment that we use. So for the pin that we use 11, 12, 13, A0, A1, A2, and A3, right? And this is the letter of the segment that we write. So this is A, B, C, D, E, F, G. 1 is equal to kind of like this, the light will be appear, and that area. Okay, and this is a section. Section will be set up. So setup will be set up these projects. So we set up the razor pin as the output because we use the razor as a speaker. And over here we use like, okay, if we use a for loop to like determine the pin or the number that we want to use. So we want to use only 1 to 8, right? So we use this to output the sound. And this is a loop of the project, so I will be explain only the basics. Okay, so this is the key, right? So over here is the note key. Okay, so when user press a button and it's equal to 8, so the bracer pin will be read, the bracer pin will be read and will be has a frequency that use frequency over here, and it will be matched to here. Okay, and the bracer will be loud sound, and its playing will be equal to true. So the piano will be playing and will be display a letter which is we set over here at the 7 segment. Okay, and over here is the delay. So it means that if the bracer is false, something like that, it's not playing, so the tone of bracer pin or the 10 will be equal to 0, so the bracer pin will be not allowed or have any sound. So this is about the 7 segment. So this is a display letter. So if the number of the keypad will be equal to 1 or 8, it will be write or display the letter. And if it's not, the 7 segment will not appear. So this is the basic of the code that we use in
So here is about the real circuit that we would like to present the piano. I set up keypad 1 to 8 as do, re, mi, fa, sol, la, ti, do. And then display the note by using 7 segment. I use 300 30 ohms as resistor and I use buzzer to make the different sound. I set up on code 1 to 8 as a different frequency. So here is our result of our project.